So can we present, sir?
Yes, you can start your presentation. You can first share your slide. Yes, visible.
Good evening, everyone. My name is Aruna. Along with my co-authors Anjusha and Haripankan are here to present our paper ID 456, which is entitled as Deep Learning-Based Monitoring and Alert System for Charging Station Cable Failure. Next slide, please. These are the contents today we are going to explain. Let me quickly walk through the introduction part. In the rapidly growing EV market, the reliability of charging infrastructure is crucially based on the charging cables, which are profoundly affected by the physical wear, environmental exposure, and so on. The Natural Renewable Energy Laboratory reports around 50% of public EV charging stations experiences operational issues. To address this, we present a method which uses deep learning technique, that is image classification, to monitor cable conditions and to predict the early failures, which improves the reliability of EV charging infrastructure. Next slide, please. In the recent days, the study shows usage of algorithms may increase the reliability of charging infrastructure. In the first paper, the authors have used the EVCs method, in which the voltage and current at the output side is monitored for detecting faults. And in the second paper, it proposes a method for fast and safe charging using the grid-connected inverter bus using the DC bus. Next slide, please. Our objectives are based on the drawbacks of the existing systems, which are as follows. One of the popular methods is to incorporate different methods of sensors, such as temperature sensor, IR sensors, for monitoring the charging cables. But some of the drawbacks includes it also includes high levelity of difficulty and expense involved in implementation, managing sensors for heavy system. By considering all these flaws, we have come up with a solution to use the deep learning algorithms with the following objectives. That is, to accurately identify faults in charging cables using image classification and to alert the UV users via GPS-based notifications and displaying only fault-free active charging stations in the user interface to enhance this user safety and efficiency. The following slides will be explained by Ms. Anjusha.
Aripan, next slide, please. So I'm going to explain about the methodology and novelty. So from the title, we'll get an idea that we are basically doing image classification using CCN. So we are also in addition using the GPS module to locate the charging station. So from this block diagram, we can see that we are using three main layers. So first one is the convolution layers. So this basically what does is that it will take an image and convert it to a matrix, that is numerical values. So mainly this layer helps us to interrupt and extract the relevant patterns. So this filter gives the information and produce a feature map. After that, we'll be using an activation function, that is a rectified linear unit. So this will provide a non-linearity in neural network. So basically what it does is from the above layer, that is from convolution layer, it gets the input, positive inputs alone and gives the same output. In case of negative, it will give us 0. So basically we are converting the images to a matrix, from a matrix to a positive values. And then we are using a max polling. So this will take the maximum value in order to take all the edges and corners. And then we'll be having the flattened layer. The flattened layer is basically a bridge between a convolution layers, that is the above layers, to the fully connected layers. So fully connected layers is nothing but which converts an image to a label. At last, we're using the softmax for binary, where we'll be getting output as a probability distribution, that is 0 or 1. Here 0 is we say it as fault cable and one has a normal cable. So basically what's our project is, we'll be placing a camera near a charging station socket. So what will happen is we'll be continuously monitoring the images. If a fault has been occurred using this image classification, that is from output 0 or 1, we will identify whether that socket has been damaged or not. Now with this 0 and 1 will be sent to the microcontroller. Here we are using the Arduino board, so which will send the SMS to the user and locate the place using the GPS. Further conclusion and future scope will be explained by Haripankam Vijay.
So good afternoon, everyone. So coming to our conclusion and future scope of the paper is that since the electrical vehicle industry is evolving so much, the detection of cable failure becomes the higher end issue to be sorted out. So considering it, we have included so many things which are explained by Anjusha and Aruna, which includes notifying the person by using GPS and technologies. Additionally, community engagement features allows user to contribute for the feedback like any other softwares which we use nowadays. And this system solves the issue of the user about misjudging the charging station which is available based on, the unawareness about the availability of the charging station, whether it is repaired or not. So that is the basic idea, and that is the basic solution which we provide from the whole system. These are some references which we took for the idea outcome. So you can have a look into that also.
Okay, your presentation is over?
Yes, sir.
Yeah. So thank you for your presentation. So now audience, anyone ask any queries? Anyone? Any query if you have, you can ask. Okay, if no one having any queries, so then I can ask one or two questions. So here, what is the use of deep learning?
Sir, basically we'll be using sensors to identify, sir. So to make more advanced technology, we are using the deep learning process, sir.
Okay, so any specific algorithm you have used for the deep learning?
So for purpose of accuracy only, sir, we are using the deep learning.
Okay, so here you have taken some images. Okay, so how many images you have handled?
Sir, for realistic monitoring purpose, we'll be requiring nearly thousands of images, sir. So in order to get more accuracy and reduce the background disturbance, but here we are just browsing it and uploading. So we have taken only 100 images, in which 80 images was taken for validation and 20 images for testing, sir.
Okay, fine. Thank you, sir. Prabhat sir, you want to ask any question?
So, okay, sir. We'll move on to next.
Okay, so next.
Paper ID 437.
Yes, sir. Good afternoon, sir.
437 available?
Yes, sir. Am I audible,
Okay.
sir?
Yes, yes.
Yes, yes. Yeah, you can present.
Good afternoon, sir. Yes, sir. 1 minute, sir. Good afternoon, sir. Hello.
Start.
Sir, my screen is visible.
Yes, yes.
Yes.
Okay. Good afternoon,
Make it
sir.
full screen. Make it
Yes,
full
sir. I
screen.
had made it full screen from my side, sir. Is it not?
Okay.
It is not full screen in our end. It may be, I think, network issue may be. Okay, you may continue.
Okay.
Yeah.
Good afternoon, sir, and all present in this panel. My name is Bhakti Thakre. I'm presenting this paper on behalf of all my colleagues, and the topic is speech to text emotion detection system using SVM, CNN, and BERT. And my paper ID is 437. In this particular presentation, I'm going to cover these many points, that is introduction, literature survey, objectives, methodology, novelty in the topics, then the result discussion, conclusion, and future scope with the references. In the introduction part, as this particular research is on the basis of the emotion detection through the help of text, so interpreting someone's emotions from the textual analysis is an extremely challenging task nowadays. So especially when the emotions typically conveyed through voice, facial expressions, and written communication. So emotions can be in the various modularity like image, audio, video, and text, all which are essential components of the human connection. So human emotions, which we can identified with the help of all these inputs, we tried to analyze all those things with the help of this particular uh, scenario, or with the help of this particular model. And the gap which we try to identify, or which we have identified, is the text-based emotion identification
Excuse
by
me.
the...
Hello. Your slide
Hello.
is not changing.
Yes, sir. Sorry, sir. Yes, sir. Now it's visible.
No. You can reshare actually. Try to reshare the screen again.
Shall I again stop and then start with my sharing, sir?
Yes, yes.
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 Okay, okay. 1 minute, sir. Now is it visible, sir?
Still full screen not visible. Your screen is visible, but not full screen.
Okay, I pressed F7 from my side, sir. It is visible on my side.
Okay, just to change the slide, check whether slide change is showing or not. To change the slide,
Yes, sir. Now it's objective on my side.
what the slide number now?
Sir, slide number 4.
4. Now it is showing 3 to us.
Okay, so I'll do one thing, sir. I will go to the next slide and then I will explain the previous. Then it may be visible to all of you. Now,
Okay.
now is it visible, sir? I think it's slide number 2 in front of you now.
Slide number 3.
Slide number 3, literature
Literature
survey.
survey. Yeah.
Yes, sir. Now I think it's working from my side also. Shall I continue, sir?
Yes. Yes.
Okay, you can continue, but slide change possible. You change, you go to slide 4 or 5. We'll see whether it is
Sir, now
coming or not.
I've changed this slide or to slide number 4.
But it is showing only 3, no change.
No change from your side. Okay, but I'm changing the slides from here.
Okay, I know. The I think network connectivity problem.
Yeah,
That's why.
there is rain coming on, so maybe because of that reason, maybe, sir. Uh,
Okay, so what will do, Manas sir? Continue, Manas sir.
Yes. Yes. There is no
Okay.
alternative. You continue.
Okay, continue.
Thank you.
Continue.
Thank you, sir. Thank you, sir. So, after the introduction, I want to say that in the literature survey, with the help of 21 papers which we have studied, I am showing only few important papers, which gives us the overall idea related to the domain of emotion detection and depression analysis, showcasing the diversity of the methodology and the focus on different aspects of text-based emotional analysis. And in this particular scenario, or in the pictures, the different authors who are focusing basically on the depression detection with the help of text images or text written texts, which will maybe an application or future application for the uh, counselors to detect the exact state of the mind for that particular person, may help the future or the society. And the basic objectives for this particular research is to compare with the existing approaches which are already present in the current work, to merge the images or with the text written values or written things. We need to identify the emotion of a person. So the three main objectives of this research is to compare with the existing approach and to contribute in the field of the text based emotion identification, and to enhance the communication between better emotional analysis and to identify the state of the person who is having in different state. So earlier detection of that emotion can be identified from with the help of this model. And the methodology and the novelty which we are trying to discuss over here is that when we take the inputs may be in the form of images, text, values, and those images can be from the social media post, chat interactions of this person or any particular human to whom we need to do the analysis. Then the sentence analysis is the like where the text is examined for the structure, syntax, and overall meaning of the statements can be analyzed. Then we in the next step we do the tokenization of the things, and the model which we have prepared, that is word, will basically work on that particular tokenization and categorized with the help of sensor emotion detection as joy, sad, neutral, anger, and fear types of an emotions. In the next slide, the result shows that the confusion matrix on the basis of SVM, CNN, and BERT, the BERT is giving a better accuracy in terms of precision, recall, and F1 score value for the inputs. And the future scope and the scopes over here in this particular scenario is that it is significance in the human computer interaction. It is basically when we are talking about the emotions, so emotions can be categorized in different types. So joy can be considered as a positive emotion, sadness is considered as a negative emotion. So on the basis of this model, on the basis of this consideration, we can say that in the early stage we can identify the emotions properly. And system advantages is one of the conclusion for this particular research, through which we can say that we can advance our computers or we can provide some advanced facilities to the society. And the future scope for this particular research is that it can assemble techniques and hybrid approaches, and we can do the domain specific emotion classifications, and it may be used in the real world application, tested on some real world applications, which will be more beneficial for the system. And the last slide shows the 21 references we have used for this particular preparation. Thank you, sir.
Okay, thank you, madam, for your presentation. So now the house is open for question answer. So if anyone wants to ask any question, please ask. Okay, so madam, you have used three tools. Why specifically these three tools are used for emotion detection?
Sir, basically the first two tools, that is SVM and CNN, are the very famous tools. So in integration with these tools, if I want to try to use the word, which is a pre-trained model in my case, so it may give a better confusion matrix and better understanding. That's why we are focused on these three tools.
Okay, so what are the specific uses of these three tools? In your work, what are the specific uses of these three tools?
So BERT is basically a pre-trained model, which is bidirectional encoder representation for transformation, which gives you or try to convert the predictions of the text and speeches in the form of matrix.
Okay. Okay. And how you have quantified emotion?
Sorry, sir.
And how you have quantified? Because emotion having different different kind of emotions. So how
Yeah.
because when you are writing an algorithm, means somehow you have quantified the emotions. So how you have
Sir,
quantified emotions?
Sir, for that, when we've written an algorithm in the model, that emotion, when it is detecting the according to the sentences or the keywords, which, for example, if I am said, so I will use those types of keywords more frequently in my text rather than the neutral and the happy type of a text. So the confusion model will give you the highest precision value for that particular number. So according to that matrix values, we can identify that whether that text will go into the joy state or in the neutral state or in the sad state or angry state or fear state, like that, sir.
Okay. Okay, thank you. And Prabhat sir, you want to ask?
Yes, yes. So,
Yeah.
madam, positive joy you have taken positive emotion, sad negative emotion.
Yes,
Uh,
sir.
so, means how you have taken, means why you have taken this thing, means some reference you have taken or how you have taken?
Sir, in the reference, when I read the papers, those papers, they have given that the modularities of the input for the text, that will be categorized according to the different values. So the data sets we have used were already the values which were present. That is, the data sets we have used is ISER and ideal, sorry, daily dialogues. So in those things or the characters which were present or the words which were present was basically over there.
And anger you have taken, which type of emotion?
Yes, sir. Sorry.
Anger.
Anger is a side of the negative emotion, sir.
Okay. Okay, madam. Thank you. Thank you.
Thank you, sir. Shall I stop sharing, sir?
Yes, yes, madam.
Okay. Thank you, sir. Thank you.
So 448. Paper ID 448.
Hello, good morning, good afternoon, sir.
Yes, you can share your slide.
Am I audible, sir? Okay.
Yes.
Sir, my slide is visible.
No, you have to share.
How?
You share your slide. Yes, now it is coming, I guess. It is
Yes.
coming. Yeah. Yeah. Make it full screen. Yes.
Now it is visible, sir.
Yes.
Yes. Continue.
Yeah.
Good afternoon, sir. My name is Anant Negi and I am presenting this topic on the behalf of Dr. Virun Mishra. And my paper ID is 448 and my topic is design and analysis of double gate vertical defects for MG2 source material for low power and enhanced performance applications. Sir, the further contents are introduction followed by the literature survey, objective, design methodology, and simulation result, conclusion, and reference, sir. So, sir, in the current era, sir, hello, in the current era, hello, sir, am I audible?
Yes, you are audible. Continue.
Sir, in the current era of the VLSI integration circuit, millions of transistors are embedded within the electronic circuits. From the simple remote control car to the sophisticated microprocessors and microcontroller. But the demand for accuracy and the precision has significantly increased, sir, compared to a decade ago, sir. So, sir, in our device, that is double gate vertical defects, the vertical structures offer better control over leakage current compared to the lateral defect, resulting in the low power consumption and enhanced efficiency, sir. So let me introduce, sir, what is TFET. TFET, sir, it is a simple PIN diode, is a device which is based on band-to-band tunneling of electron Due to this tunneling mechanism, switching between the on as well as off current occurs at very low operating. These operating low voltage is much less than the MOSFET. It is therefore expected, sir, to reduce the power consumption and the of the electronic device, sir. Sir, in this figure, I can show you that the electron of the in case of MOSFET, these electrons first jump to the conduction band, then move to the channel. But in case of TFET, the electrons are directly penetrated from the source and to the channel side, due to which very low voltage is required to operate the TFET, sir. Working of TFET, sir, I have already told you, when a voltage is applied at the gate terminal of the TFET, it creates the electric field at the heterojunction. This voltage is typically very below the threshold voltage of the conventional MOSFET, due to which we are getting very low voltages and very high current and making it suitable for the low power consumption device. Sir, on the basis of studying all the 15 research paper, but I have only included the 5 research paper in this. These are the advantages and the disadvantages of the research paper, due to on the basis of which we have improved our device and make it suitable for low power consumption device. Sir, our main objective is to achieve the less sub threshold swing in TFET, achieve low leakage current, increase the on current of the TFET, decrease the ambipolar current, and reduce the transit time. And at the last, sir, biosensing applications, we have to show the example of bio application sensing with the help of this TFET, sir. Design and methodology, sir. Sir, in simulation of the device, we uses several models involving the Shockley red Hall recombination model, and sir, non-local band-to-band tunneling model is also used. And sir, several other models are also used. Sir, the problem identification we have done, first of all, that is getting low current in the TFET. Second, literature survey, and at the last, sir, we have added the Mg2GE source material in our source, due to which Mg2GE, sir, we have added because of the low band gap material as compared to the silicon. The Mg2GE band gap is 0.67 volt at the room temperature, as compared to 1.12 volt when compared to the silicon at the room temperature, sir. So these are the design and the device dimension of the proposed device. And the electrical performance, now we have, sir, carried out the electrical performance. Electrical performance, sir, is very crucial in case of vertical TFET, because it directly impacts the overall efficiency and reliability and the applicability of the device, sir. Sir, in case of, now here you can see, in case of silicon, we have the valence band is very less than as compared to the Mg2GE conduction band, due to which we are getting better result as compared to silicon. So band-to-band tunneling electron, due to the low band gap material we have used, we are getting higher band-to-band tunneling rate in the channel, and our drain current is increased by the order of 2, sir. In silicon, we are getting 10 to the power minus 14 as compared 10 to the power minus 4, minus 6, and in case of Mg2GE, we are getting current as 10 to the power minus 4. Hence, our current is increased by the 10 to the power minus 2. That is huge, sir. Sir, now coming to the transconductance. Sir, in our case, we are from 0.2 voltage. We can observe that our transconductance is high as comparison to the silicon, and due to which it is making it suitable for the low power device, sir. Coming to the, sir, transit time, sir, the lower the transit time, the lower the response time of the device will take. As in our case, the transit time is 10 to the power minus 6 micrometer, and whereas in silicon we are getting the transit time at 10 to the power minus 4. Due to this increase of 10 to the power 2, our device switching ratio is increased significantly, sir. Sir, coming to capacitance graph, comparison of CGG, that is gate to gate capacitance. Higher capacitance can enable faster charging and discharging of the device that lead to quicker transition between the on and the off state. This is beneficial for the high speed application, sir. Conclusions, sir, based on the comparative analysis between MG to GE based on vertical defects and silicon based defect across various performance metrics, we can conclude that by incorporating the MG to GE in the source side, we have achieved higher on current. In case of MG to GE based DG to VT FET, we are getting on current at 0.1 milliampere, whereas in silicon based DG VT FET, on current coming out to be 1 microampere. That is very low as comparison to the on current. On current is increased by the order of 2. In MG to GE based VT FET, leakage current is decreased by the order of 2 when compared to silicon based DG VT FET. MB polar current, sir, when the voltage is 0, and if the voltage is reversed, i.e. voltage, then also we are getting low current in case of MG to GE DG VT FET, and the order of 10 to the power when compared to SI DG VT FET, sir. Due to which means that the low battery consumption when the device is off, sir. Sub threshold swing is increased significantly, sir. In MOSFET we are getting 60 millivolt per decade, but in case of VT FET we are only getting 35.60 millivolt per decade, sir. Cutoff frequency is very low in case of MG to DG VT FET as comparison to silicon based DG VT FET, sir. Sir, as I have already told you, transit time is reduced by 10 to the power 2 in MG to DGVT FET, which means that response of the device decrease, which results in increase the speed of the device, which make it suitable for RF circuits, because in high frequency applications, minimizing the transit time is crucial for achieving the fast switching speed, sir. Thank you, sir. Hello.
Thank you for your presentation. So anyone have any question to ask? Anyone? Okay, if there is anyone wants to ask. Okay, so what is the motivation to choose this MG to GE with the what is the conventional material used for TFET?
Sir, MG to GE, sir, we are in MG to GE, we have very low band gap material, that is 0.67, due to which the band gap, tunneling of electron from the conduction band, valence band of the source side will definitely be increased.
Yes, now that you have established, what I want to ask you that what means from the literature you found that you can use this material MG to GE for the TFET fabrication. What is how you come up with MG to GE? That I want to know.
Sir, actually, in one base paper, sir, I have seen that there is MG to SI is used, but
okay.
I have also inserted MG to G because it was getting. When I have compared the result, I have also compared the result of MG to GE with MG to SI. In case of MG to GE, no one has used MG to GE. So due to its novelty and getting better results, I have used it, sir.
So is there any disadvantage you found in your research to use MG to GE for the TFET development? Any disadvantage? Any disadvantage?
Sir, any disadvantage? No, sir, no.
Okay. Okay, that's all from my side. Prabhat sir, if you want to ask, you can ask.
Okay, okay. So, where are its application actually? Tell me some applications of this MG to GE.
Sir, actually, the device that we have proposed, sir, this device we will use in biosensing application that we are working on, sir.
biosensing applications.
Yes, sir. We are working on it, sir. Till now,
Okay.
only we have increased the electrical performance. We have improved the electrical performance of the device, sir.
Okay, so now that means you have verified that they are performing better. After that, you will apply.
Yes, sir. Now we will apply it in the biosensing because, sir, in cell, every cell has, for example, every cell has particular dielectric constant. With the help of the dielectric constant, we will able to identify that the cell is cancerous or non-cancerous, sir. Because,
Okay.
sir, healthy cells have a dielectric constant of 32 to 35, and in case of cancerous cell, it is of 4 to 5. So with the help of the dielectric constant, we will able to apply the concept, apply this concept in case of biosensing, sir.
For diagnosing. For diagnosing.
Yes, sir. Yes, sir.
Okay. Okay. Good.
Yeah, Acha, one thing I want to ask, you are a BTech student?
Yes, sir.
Hello?
Yes.
Hello. Yes, sir.
You are a BTech student?
Yes, sir.
BTech which year or which semester?
Sir, last, sir, end.
Okay, okay, thank you.
Yes. Thank you, sir.
Thank you. Thank you.
Next paper is 453.
Mahesh Pal Singh?
Sir,
Yes.
good afternoon.
Yeah. You can share your slide.
Sir, is it visible, sir?
Yes, it is visible. Go to the first slide and make it full screen.
Okay, sir. Sir.
Yeah.
Sir, I am audible, sir?
Yes.
So good afternoon, sir. My name is Mahesh Pal Singh. I am a PhD scholar at NIT Silchar under the supervision of Professor Nijal Sinha, sir. So my topic of presentation is data generation using Latin hypercube sampling approach for power system dynamic security assessment. So these are the contents of my slides: introduction, background, objective, methodology, results, and conclusion. So come to the introduction. The power system security is the very important, which can be defined as the ability of power system to maintain stable level operation despite any probable credible contingency. It ensures that the system should be in viable state of operation. So the main focus in the operation control center is to the system monitoring and contingency analysis and corrective actions. It can be found with the help of security constant optimal power flow. So in today's modern power system, ensuring security is more critical than ever due to the increasing complexity and evolving threats. This is because the integration of renewable energy generation and non-inertial types of demands like electric vehicles, which are making the power system more complicated and vulnerable. So for that, the operators required robust methods to ensure power system operation under normal and abnormal situation. As we know that conventional approaches are time consuming and inaccurate due to approximation in the mathematical modeling. So we need some latest approaches approaches that are based on the ML machine learning are effective for the complex task, but they require the extensive data set for the training. In the case of abnormal situation, the simulation data can be used to generate the rare event scenario that historically it is absent in normal case. So the high quality information rich data set are essential for training the models to assess and manage the stressed operating condition in power system. So it will be helpful to enhance the dynamic security assessments. So for that, in previous literature, the brute force of techniques is applied for the sampling. In this case, all the possible solutions to a problem is analyzed or assessed. This is the mathematical expression for this VF technique. So as the system size becomes large and complex, so there is some problem with that technique, because it is impossible to evaluate all the operating points for a small system. Like here the two cases are considered, like 14 bus system and 57 bus system. So for with that techniques, around 2.56 million operating points for 14 bus system and 3.9 into 10 power 15 operating points for 57 bus system are required to assist. So it is very hard and time consuming. So here in this work, latent hypercube sampling is used for that work. So it can sample the sample uniformly, and it can travel whole space and cover whole space of operating region. So comes to the background. This figure shows the criticality, safety criticality of the power system. So this is the case of blackout 2012 northern grid failures, which affected almost 600 million pupils, and it took 15 hours to restore 80% of services. And it was again failed on 31st July due to relay problem. So these type of cases motivate us to find the approaches that are fast and fast to assist the operating power system operation to avoid any blackout. So for the sake of the reliability and cost effectiveness, it is most important to guarantee that safety of power system operation. For secured power system operation, operators must require everyday a security assessment, which is in which the security assessment they screen the contingency list every 15 minutes and prepare contingency plans for critical scenarios. And they run both steady state power flow to check n-1 contingency and violation limits for the dynamic simulation. So as we know that in the modern power system, PMUs and smart meters provide data that drives machine learning advancement, but before their uses, they require the intensive training. So the development of efficient database for quick power assessment in stress condition is the open research topic. So the objective of this work is that as we know that machine learning model performance relies on the robustness of database to address the security under abnormal situations. So we have to generate the data set. The data set should be small in size and highly informative in nature, so that the machine learning algorithm should be fast and accurate. So in this work, the LHS based techniques is used for that database creation. These techniques employs the converts relaxation certificates. These certificates helpful to examine the highly informative regions for specified secure operation threshold, and they are helpful to construct a comprehensive data set that encompass all dynamically critical operating stages of power system in a very efficient manner. This work is done offline, and this after doing this training of ML in offline mode, the model can be used for the real-time security assessment. So this method combines the L-1 security and small signal stability criteria as a security threshold. So this case illustrates the importance of generating database by utilizing ML classification model SBM to achieve fast and efficient data-driven security assessment. So in this methodology, this is the LHS approach in which the points are selected from each columns, only one point, and at every iteration the location of these points will be changed. So in that manner we will cover all the operating region, and the data set size of data set is also small. So so in that case it is informative and compact also. So this approach outperforms in both probabilistic load flow and uncertainty analysis. So this is the mathematical formulation for the used security threshold as small signal stability, which is based on the damping ratio sensitivity, and these are the operating points which shows the high informative regions, in which the del k is the security threshold, and mu is the deviation from that security threshold. So these are the power balance expressions and net power flow, complex power flow from buses. So after that, using that technique and preparing the data set, this data set can be used for the SBM model training. The purpose of this model is to perform a direct mapping for rapid security evaluation. So various generation operating set points, including bus voltage and line flows, are chosen as a predictors, and the SBM based model is used to predict the state of the system, like it is L-1 secure or small signal stable or both. So in this both cases, 14 bus system and 57 bus system, there are 20 transmission line in 14 bus system. Out of this, 18 transmission lines are selected for the contingency, single line contingency, and for 57 systems, out of 80 lines, 53 lines are considered for the single line outages. So in this this techniques, as using the BF technique, brute force techniques, we evaluate 25 lakhs operating points. But when we increase the size of the system, like 57, so this techniques is infeasible for that. So for that, we use the LHS and generate 1 lakh of operating points, which are sufficient to cover the all operating region. These are the scatter plot of this data set, which showing in terms of the generator combination for the security threshold L-1 security and small signal stability. So these are the specific combination of set points for different generators, G1 to G4, because there are 5 generators. So one is slack bus generator and other four are changed their combination. So these are the feasible region identified for that system, and this is stability region. So the same case is applied for the large system like 57 system also. So in that also we generate around 1 lakh of operating points for the L-1 security and small signal stability with the 1 megawatt of step size. So for that system, 57 bus system, these are the scatter plot.
Excuse me, Mahesh, your time over, so kindly conclude.
Okay, sir. So these are the generated data set, and these are similar for as in 14 bus system. So after the generating data set, here we have trained the support vector machine model. So this graph emphasizes the accuracy in the classification of L-1 security and small signal stability, which is 100% for the 14 bus system, and here it is 96% for the 57 bus system. So in conclusion, we have generated the data set, which is small and informative also, and infeasibility certificates are utilized to improve the quality of data set. So this data set is employed to train the SBM for the considered security threshold. So once the SBM based machine learning model is trained, it can be utilized for predicting the current operating state, including the margin of the stability in real time operation also. So thank you, sir.
Yeah, thank you. And we will take some quick question because already time is over.
Okay, sir.
So can anyone ask, or anyone is interested to ask any question? Okay, quickly I'll ask that why you are giving the emphasis on SVM only? Because SVM is generally used as a classifier. So
Yes, sir.
in your case, how it is going to help? Why
Sir,
you are giving emphasis on the SVM only?
Sir, we can use other models also like decision tree and other also, but in my case, because I have prepared a data set in which I use the transmission line flows, system bus voltages, and the generating set points as a predictors, and the states like L-1 secure, small single stable, or both, like, or none, like, as a output. So as a based on that, because my task was the classification and regression, so that's why I use that SPM model, sir.
Okay. So are you doing nonlinear regression also?
Sir, yes, sir.
Okay. Prabhat sir, quickly you can ask.
Yes. So that means for IEEE 14 and 57 bus system, you are generating data, right?
Yes, sir.
So now you please clarify what is that LHS based dataset generation method and how you are taking the different critical situation, for example, fault occurs or something like that, how you are taking actually, means including those things.
Sir, actually, first of all, I covered entire operating region, like that. If the generators limits are from 0 to 100 megawatt generation,
Okay.
so for every generator I considered the full limit, and based on the step size, I covered entire region of operation for all combination of generator set points, and selecting a contingency list, like in case of 14 bus system, I selected 18 lines. So I check the security limits, that whether my system violating the voltage limits or violating the transmission overflows, like that. So based on that, if it is not violating for all the set of contingency, then it is secure for L-1. And for the small signal stability, I consider the damping ratio, like eigenvalue sensitivity, damping ratio in terms of eigenvalue sensitivity. So the value I choose here is 0.3 for the small signal stable. Above that it is stable, and below that it is unstable, like that. So these two criteria I set and check for every point, and after that I classify them for the uh, real time operation.
Then now how can you confirm that these data are for fault situation?
Because sir, I considered contingencies, I considered.
Okay.
Huh.
And
I considered both
that,
cases, sir, intact cases as well as the contingency case.
so my query is how you are giving fault situation.
Sir, I create that in the simulation using the security constant optimal power flow in MATLAB.
Okay then. Good. Thank you.
Okay, sir. Thank you, sir.
Okay, thank you. So next presenter.
It's 458.
458, yes.
Yes, sir. Hello.
Yeah,
Yes.
can you share your
Yes,
slide?
Yes, sir. I'm sharing. Is it visible, sir?
Yes.
Yeah.
Can you make it full screen?
Yes, sir. I made it full screen, sir.
Okay. Just to check that whether slide is changing or not. Just to go to the next slide.
Yes, sir. Is it visible, sir?
Have you changed?
Yes, sir. 1 second.
No, only your title slide is showing.
Now I'm sharing.
Now you make it full screen.
Is it visible, sir, now?
Yes, now it is visible. You change your slide just for yes, fine. Now, yeah, you can start.
Thank you, sir. Good evening, everyone. So my name is Chaitanya. I'm here to present my project named Data Poison Detection Schemes in Distributed Machine Learning with the help of cloud computing. And regarding to the contents, I want to explain about the introduction, literature survey, objective, and the methodology involved, results, and then conclusion. Introduction. In the present world of distributed machine learning, which relies on the cloud computing resources, maintaining data integrity and security is very much important. And mainly the intruders, where the large amount of data set is involved, the intruders are mainly focusing on changing the data, and which results in the great amount of loss while training the machine learning models. So we have been first looking after the importance of the distributed machine learning in the recent years. Like evolving of the technology, machine learning models are more and more increasing, and to the threats are also increasing. Like for example, in our project, we have been basically used in hard disease data set, where we have included some small amount of data set, which includes the BP percentage, like blood percentage, BP, and etc. So in that, if any hacker is involved and changes the data, it results in the changing of the person's data set of his health history, his or her health history. So regarding the literature survey, in the previous research, I have found that they have shown some of the autoregressive models, and they have focused on data poisoning attacks against the autoregressive models. Autoregressive models are the models which are focusing on the prediction. And in this, the Kalni and Wagner have told, these authors have told that there are many data poisoning attacks that have been happening mainly on the machine learning models. They haven't shown the types of the attacks, and they haven't presented the percentage of how much attack is been happening. And in our project, the main objective is that to identify the detection accuracy, and it also is very, and our project is very much scalable and efficient. It also uses the large amount of data set, and it is adaptable to any cloud environment. And the methodology that has been involving in our project is that with the help of the existing project, that is SVM, support vector machine, with the help of it, we have been developed two methods named DML, distributed machine learning, basic DML, and semi DML. Basic DML uses the help of existing SVM and the basic DML. Both the process will be happening in the basic DML. But coming to the semi DML, it works on the whole data set with the help of some of the resources that it required. It works only one, like in our project mainly, we are taking one data set, sir. After that, the data set will be divided into, based on the data set, it will be divided into further parts. Suppose if the data set, if we have only two workers working under the, under the central server, the data set will be divided according to the number of workers. These workers compares the poison data and the unpoisoned data. Since we have been developing the project, we have been using the poison as well as the unpoisoned data. We will be providing the poison data to the workers so that the workers will compare, and with the help of the existing SVM result accuracy, they will be comparing both the accuracy, and they will be sending the overall accuracy through the basic DML. But coming to the semi DML, uh, the persons are working only on the whole data set without dividing of the data set. They are working on the whole data set, and the semi DML doesn't uses the existing SVM or basic DML. It shows the accuracy based on that. So semi DML is the efficient resource management, and also that these are the results. Initially, we have been we have been using the Kinta framework in our project, and we have been uploading the dataset, and after that dividing the dataset, and the divided trained dataset will be distributed to the workers accordingly. So overall, our project shows that since the machine learning models are being main part of our present tech world, we have been focusing on which type of, whether the data has been poisoned or not, they can check through our platform. And before I mean, like whenever the data is injected, I mean, like whenever the data has been uploaded through the cloud, they will be check the accuracy. Like see here, the existing SVM accuracy is very much, I mean, like it has been not showing the exact accuracy. I mean, like not it's showing not how much data has been poisoned, but coming to the semi-DML, it is showing that the much amount of data, sorry, and it is showing that the how much I mean the accuracy of the data, I mean data has been poisoned. So in our project we come to the conclusion that in our project semi-DML is the best methodology which will be helpful for us to find the poison data. I mean, like we can't check through which data has been poisoned, but we can know that our data has been poisoned, and the accuracy, I mean, like how much amount of data has been poisoned can be checked through our project. And coming to the conclusion, like in day by day the technology has been evolving, and the hackers are also injecting the malicious data into the large amount of distributed data sets, which is the help of the cloud platform. In this project we have been using a demo cloud, and in the future, I mean, like we can develop this project with the help of, I mean, finding the which type of data has been poisoned in the large data sets. And also this project is very much helpful to adapt to the changing of the application environments, and will be showing the accuracy percentage too. And in the future, since there are a number of the models are been increasing, they can check through our platform to identify the amount of poison data that have been got injected by the intruders. That's it, sir. These are the references which we have been using in our project. Yes, sir. Hello.
Yeah, thank you for your presentation. So anyone having any question, you can ask. Okay, so can you tell me that what exactly your contribution, because I'm a little bit confused.
Yeah, sir. Mainly our project is concentrating on, let me tell you, like we have been taking an example of an hard data set. Suppose it contains exactly like 300, I mean like 300 fields of information in that. And if anyone, like some other ex-person who is outside the organization, I mean, modifies the data, I mean, like it will be changing the profile of the person. I mean, like health history of the person. So it will be resulting in a lot of loss to that person. So we have been identifying whether the data has been poisoned or not through the accuracy. I mean, like
So what is the percentage of this poison? Means suppose you
yes, sir.
have 3,000 of data and only suppose 1% of data has been changed.
Yes,
So
that's what I'm
your
saying.
algorithm, yeah.
Yes, sir. In the semi-DML, as I've shown the result for you, the semi-DML accuracy will be showing, I mean, like 60% of the data has been poisoned. Like that, it will be showing you the percentage, sir.
Okay.
When I mean, like the users need to upload the data into our platform, like it will be only used, I mean, like it's not a website, sir. We are using a Kinter framework, and it will be directly uploaded into our local machines, and the persons can upload the data set into the platform, and they can check through the, I mean, like they can check the whole data set whether any poison is happening or not, any data has been injected or not.
Okay. Prabhat sir?
Okay, so my question is there any threshold value? How much of poison will be okay or how much will be dangerous? Is there any threshold value?
No, sir. No, sir. We have.
For example, 5 to 10%. No issue, I think. Or
yes, sir. Yeah, that's what we are checking, sir. Whether, I mean, like large amount of data has been injected or very much small amount of data has been changed. We have been checking through that. Yeah, that's what.
for example, the change of profile. So how much percentage of means data will be poisoned, then we can change the profile. 40%, 30%, like this. Is there any threshold value?
Yes, sir. I mean, like before, I mean, like when after entering a whole data set, I mean, like after entering all into the Excel format, once they will check whether the data has been poisoned or not. I mean, like how much percentage is there without the poison data. And after after the modification of some values, they will check the accuracy again, and they will find the difference in without the poison data, and with poison data they will check the accuracy, sir. Yes, sir.
Okay. Okay.
Yes.
Good.
Thank you, sir.
Thank you. Thank you.
Yeah, 459.
Yes, sir. 1 second.
Okay, can you go to your slide number 1, because it is showing slide number 5.
1 second, sir. 1 second. Yes, sir. Hello,
Yeah.
Manas, sir. Hello, Prof, sir. Hello, everyone. Now you can see my screen, sir.
Yes, yes, you can.
Yes, this is my Sandhir Kumar Singh, and the paper ID for this 459, and I am presenting the title of the paper is Optimal State Estimation and the Navigation of AUV using Kalman filter. I will present on the behalf of my all the co-authors. One second. This will be the content of this topic: introduction, objective, and the algorithm. Kalman filter algorithm is used for this project, and the sensor fusion, and the sensor involved for this project. Then next one is the system dynamics, methodology, and the Simulink model, and result discussion, conclusion, and future scope. This is the actually what we are doing for the introduction of this paper is that we will take the data from the different combination of the sensor, and we will try to means estimate of all the state of the system, means all the linear position in all 3 directions and the angular position of the autonomous underwater vehicle in the all 3 axes like roll, pitch, and yaw. For this project, we have used 3 sensors like in inertial measurement units. This is the 9 DOF sensor, Doppler velocity log, and the pressure sensors. Means our objective for this topic is this to get the exact position of the means AUV and inside the water using this 9 DOF IMU sensor, DVL, and the pressure sensor. This is our algorithm. This means which algorithm we have used for the estimation of the all the states of the system. This is our means state model of the system. This is the second equation is the measurement model. This, and what we are doing, the first we will predict the system using this prediction model. Then after getting the measurement from the sensors, we will correct the whatever we have predicted here. Means sensor fusion means definition of the sensor fusion means we are taking the data from the different sensors, and we are fusing using the Kalman filter algorithm, and after that we will get the correct means correct state of the system. That maybe we are getting the whatever the data we are getting from the sensor, that may be noisy and all. So what we want to is sure that whatever data we are getting, that should be very correct. For that we have to use this IMU sensors, which will give the this is 9 DOF sensor, which will give the acceleration in XYZ, and this angular velocity in XYZ, and the magnetometer also has been used for this one. This DVL will this is the Doppler velocity log. This will directly give the velocity of the system using Doppler effect. This is a pressure sensor. Pressure sensor data will give the height of and depth of the AUV from the seabed. Estimation capability using the IMU. After integrating this, we can get the velocity and the position of the system. But the problem with the IMU is that after integrating, we will get the drift in the system that we want to correct using the DVL and the pressure sensors. This is our sensor model, means error state estimation. What actually we are doing means we are not directly estimating the state. What we are doing here, directly we will estimate the error of the system, how much error in the sensors. So for that, this is our error state system. For directly, this is all the state of the system, like total 21 state. This is 5x, 5yz. This is the misalignment angle between the frames, like that earth frame and the navigation frame. There is the velocity error. This is the longitudinal, lateral, and height. This is our the accelerometer sensor wise, gyroscope wise, and this is our DVL frame wise. This is the KD, that is the scaling factor for the DVL, and this is the pressure sensor wise. After this is our state matrix. F and G is the input matrix. This is the Y, and this is a noise. This is what will be the our measurement, means our measurement will be the DVL measurement bit and minus of this scenes, means the IMU measurement. This will be our measurement from the sensors. So actually, what is our methodology? We have tried with two methodology, means two set of combination of sensors. First combination of sensor, this is the DVL sensor, this is IMU sensor, and this is a pressure sensors. So whatever we are getting the sensor data from the IMU, after getting the data, IMU will give the acceleration and the means angular velocity, and this is the from the magnetometer we will get the orientation. After this, we will integrate this. We will make this will give the velocity in after integrating. We will get the velocity, and this velocity will be in the navigation frame. This we have to try to this make in the one frame. So we will get, after getting, we will convert in the body frame, but we are comparing the means our scenes velocity with the DVL frame. So we need to convert this in the DVL frame. After getting this error we will calculate here from the DVL data and with the scenes data. This error will be fed to the Kalman filter. This data will be observation for the Kalman filter, and this Kalman filter will estimate this error, and this error again to fed to the DVL sensor, so that it will compensate with the whatever the error we are getting from the sensors. Same way we are getting the height, we will integrate this IMU sensor twice, so that we will get the height in the z-axis, and this pressure sensor will also give the seabed height. So this difference also will be fed to the Kalman filter. After Kalman filter will estimate this height difference error, and this will be sent to the pressure sensors again. This is one methodology, and second method we have used with the 2 IMU. Means for this what we did means we have integrated the accelerometer data from the both the sensor and fed same thing we have set this observation as for the Kalman filter, and we have estimated the position for this AUV. And for orientation, we have only used this IMU only, means accelerometer, magnetometer, and the gyroscope. This is our simulation model. What we did here means we have created the whole AUV model in the CMSCAP, where we have given the input. Input means for the linear movement, we have given the linear force. For the angular position, we have given the torque on the this mass. And after that, we have seen the movement in the CMSCAP. The sensor will record all the movement of the body. After that, we are getting the data. We have this data we have simulated, means fed it through the algorithm. Algorithm has estimated all the state, means linear position and the angular position in all three directions. Here we can see here this for the verification purpose, one sensor we have used in this in the CMSCAP, that is a transform sensor. What it will do, it will measure the means true value of the state. Means from that, whatever we have estimated here, that should be verified from with some data. Means here we will get all the position and the orientation, so that we can verify whatever we have estimated, that is correct or not. So these are our results. These are our linear position. This linear position using the IMU, DVL, and the pressure sensor. So what we can see here from the result, this is our this all three axes, X, Y, and Z. So if we see this, one is the true value, one is the estimated value. So from the using the sensor like IMU, DVL, pressure sensor, we can see that both are following each other with constant error, X and Y, because we have given the force in the X and Y only. We have not given the force in the Z. So there is no movement in the Z. Same way, if we see here in using two IMU sensors, it is coming initially, it is following is that after some time due to drift, it is deviating from the true value. So we have compared that key using the IMU, DVL and pressure sensor. It's better to use that IMU, DVL and pressure sensor combination of sensor for the better estimate of the position. This is the same error plot for this one. Same, we initially it is fluctuating, after that it is becoming constant error. But using two IMU sensor, if we see, this is exponentially increasing, error is exponentially, so because of the drift only. This is our orientation. For the orientation, we have used single IMU sensor, means this accelerometer, gyroscope, and the magnetometer. From this, we can see that it is following. This is perfect. We can use the IMU, only one IMU sensor. The error is most probably just it's similar, okay, 0. Discussion from the above plot, we can see that key means IMU DVL sensor error is constant over the time. For the position orientation, we have used 9 DOF sensors. And for the conclusion, this paper presents the comparative study of two methods for the optimal state estimation of the AUV using sensor fusion. The first method using IMU sensor to estimate the position and the orientation, and the second method using IMU DVL and PSS sensor to estimate the position of the AUV in complex underwater vehicle. For our analysis reveals that the orientation estimation using IMU sensor is preferable, as the orientation error by this method is close to 0, while the position estimation using two IMU shows an exponential increasing error, making it unstable for the accurate navigation and localization. The second method using IMU, DVL, and the pressure sensor provides a constant error plot, and it's recommended for the position estimation. For the future work, the potential for the exploring the landmark based, what means the next part of this project means we have to localize the autonomous underwater vehicle with respect to any landmark in the local frames. For this one, we have to use the vision based technique and using the camera data. These are the references for this project. Thank you, sir.
Okay. So are you a MTech or PhD student? Or?
No, sir, I actually completed the MTech from NIT Rourkela only. Currently, I am working in Bangalore.
Bangalore. Okay, fine. So here, the data, what you have collected from the sensor, all their real data, or it is
no, sir. Actually, data? What we have did means we have created, we have taken one there's one box, this box on which we have created in the CMSCAP. We have given all the X force and Y force in the X and Y direction, so that that metal box will start moving. From there, all the sensors, such IMU sensors, DVL sensor, all the sensors are attached there. From the movement, the sensor will record the data in the CMS. Everything is done in the MATLAB environment only. From there, we have getted all the sensor data. After recording all the data, we have fed to the Kalman filter algorithm to estimate this.
So the noise you have added, or it was?
Yes, I have added. Yes, I have added from the.
But here you have not shown what is the covariance, what is the noise properties you have not shown. That what are the noise you have considered here?
Yes, sir. I think in the paper it's given whatever the noise parameter we have taken for the IMU. Basically, for the IMU only we have considered all the noise. So in the paper, I think it's added there.
Okay.
In the table form, it's added.
And how many times you have run this program? Because repeatability or reproducibility is also important. Means how many set of run you have done to produce your result?
Yes, sir. So during my MTech time, we have run so many times for this to get the result. So, but the final result we got is this one. Means after that, this was correct only. The only varying when we are giving the extra input of the noise, that time it was varying so much. So
okay, Prabhat sir.
Okay, so you have used Kalman filter for estimation of what?
Estimation of the state means all linear position of the all three direction and the orientation.
Okay, now my question that what is the order of this covariance matrix?
total covariance matrix will be, sir, 21 by 21, sir.
Yeah, that's why I'm asking. So then what is the demerit of this Kalman filter? That inverse term is there na in Kalman filter. If order is very high, inverse is there na in Kalman filter equation. That inverse term is there na.
Yes, yes, it was in the Kalman gain, sir.
Yes, Kalman gain. So if the order is very high, then you will face no
Yes.
problem.
That is the demerits for this one, sir. Because if we order will be, so it will be very, so it will take so much time to compute the inverse for that one.
Yes. There are
For this
some
one,
other variants of Kalman filter people are using. You know any other variant of Kalman filter?
yes, sir, extended and adaptive Kalman filter and all. So many Kalman.
Okay. Okay. Good. Thank you. Thank you.
Okay, sir. Thank you, sir.
FRIT 466.
Sir, yes, sir.
Okay, start your bill.
Okay, sir.
Okay, sir.
Good afternoon, sir. I'm Sandhya from Rajalakshmi Engineering College. My paper ID is 466. I'm going to present a topic, a battery charger for electric vehicles using a zeta converter. My contents are introduction, literature survey, objective, block diagram, methodology, results, and conclusion. My proposed work explores the use of a zeta converter for battery charging in electric vehicles powered by a PV system. The zeta converter is used for regulating the PV output. The peak power of 2 kilowatt PV system, peak power of 2 kilowatt PV system is used, and 12 volt lithium ion battery. And the the zeta converter will regulate the voltage up to 24 volts. By efficiently converting the power, it will reduce the energy losses and improve the overall efficiency, charging efficiency. I have used the Petrov and observe maximum power point technique to ensure the PV that will operate at the maximum power output. Zeta converter will maximize the energy harvested from the PV array. The flowchart of P and O method is, if the P and O method will take the slope in the graph, that the slope will be from P power and voltage. So it will take the slope, and if it will, if the ratio of power change in power and voltage is lesser, it will shift to leftwards. If it is greater, it will shift to the rightwards. The then the literature survey, I have explained 5 literature survey. First is for first is for the ultra fast charging of electric vehicles. It uses the internal combustion engine and rechargeable electricity battery. The battery is replenished during motion through regenerative braking. The charges will occur via external electrical outlet. It will use DC to DC converter incorporated with the design to charging. And the second is PV based grid in PMBL BLDC electric vehicle with high gain interleaved DC epic converter. It will use the it will also serves the transform voltage levels. The DC to DC converter will be used, and it will be used for battery charges, which is constructed using traditional buck boost, and SEPIC converters also used in this. Here for high gain renewable DC to DC converter for renewable energy application and economic dispatch problem in power systems. Then off-board electric vehicle battery charger using PV array. my objective is to design a simulation of 2 kilowatt PV system integrated with zeta converter and voltage source inverter to validate the performance of BLDC motor under varying irradiation conditions. This is my block diagram. In my block diagram, I have PV array, zeta converter, voltage source inverter, and BLDC motor. The electric commutation is used, and the battery is used for if extra power is there, it will store in the battery, and P and O MPPT is used. My methodology is for the PV system will have a peak power of 2 kilowatt under standard conditions, which will have a irradiance of 1000 watt per meter square and a cell temperature of 25 degrees Celsius. It will use the P and O method to adjust the operating voltage and to track the maximum power point. The zeta converter is used to manage the power flow between PV system and the battery unit. The converter will operate in two modes. One is on mode and off mode. In on mode, the converter charges the inductors and capacitors. During the off mode, it discharges the stored energy to the load. A voltage source inverter is used to convert the DC power from the battery or zeta into AC power, and it will convert it will drive to the BLDC motor. BLDC motor is used for its efficiency and reliability, and its performance is very good. So it will be used in the electric vehicle, and I have simulated the model and I have given the results. First result is the PV power output. The peak indicates the high solar irradiance and when the system is generating maximum power for battery charging. Second one is the converter output. DC to DC bus voltage from the zeta converter over time is shown in this DC bus voltage. And the third is the current waveform from zeta output current, inverter and battery current are shown in this. And this one is line to line voltage. Line to line voltage is taken from the inverter, voltage source inverter, and the stator current and EMF of BLDC motor is shown in this, and the rotor speed of BLDC motor in the torque, electromagnetic torque output is shown in this. The battery characteristics conclusion. The PV integrated zeta converter with battery charging feeding BLDC motor is analyzed. Motor dynamics has been implemented in this proposed work. The P&O maximum power point algorithm has been utilized to make the PV system operate at its peak power. Efficiency of the proposed system is studied through the MATLAB. Simulation outcomes are of the operation of the converter is used in both buck and boost modes. Future scopes: implementing advanced control strategies such as predictive control or model predictive control can further improve the dynamic response, stability and reliability of the charging system. These can be used to help easy integration with different types of PV arrays and EVs. And these are the references I have taken.
Okay. So any question from participant end? Okay. So you are a student of BTech or MTech or PhD? Sandhya?
ME, sir. MTech, sir.
ME. Okay.
Yes, sir.
So now, where is your schematic diagram of the whole system?
There's simulation diagram. Simulation diagram.
This one. Okay.
I have
This
included in the papers. This one is block diagram, sir. Block diagram.
Okay, that block diagram I am asking. Okay,
Yes,
PV array, zeta converter, P and O MPPT, battery. So now, okay, now tell me what is the specialty of this zeta converter over conventional converter?
The zeta convert I have tried using Zeta converter, sir. Actually, I started my work now only. Out of interest, I have taken the paper and I have studied. So I have implemented the Zeta converter in my own interest, sir.
Okay, the performance of this Zeta converter with conventional converter, you have not compared?
No, sir.
Okay. Okay. In simulation, you have verified this thing.
Sir?
In simulation, you have verified only, no hardware.
No, sir. I have we have our UG students actually done a hardware. I have seen that, sir. Now I got an idea. I will do in my future, sir.
Okay, so here BLDC motor represents what? EV charging, EV motor.
Yes, sir. EV charging, sir.
Okay. Okay, then good. Okay, thank you.
Thank you, sir.
Next is paper ID 468.
Yes, sir. Am I audible?
Yes, audible, audible. You can share your screen.
Sir, is it visible?
Until now, no. You said till now
Sorry,
not visible. Till now not visible.
not visible.
Not visible.
Sir, I'll
Now
do.
can now visible. So make it a full screen. Huh?
Is it now full screen?
Yes, yes. You continue.
Okay. Okay, thank you. So my name is Lippy. I'm from DTU and my paper ID is 468. The topic of my paper is reconfigurable silicon nanowire based Schottky barrier transistor for pH sensor, a comprehensive study. Here are the contents. The contents involve introduction, literature survey, objective methodology, results and conclusion, etc. Introduction. pH, basically it's a pH sensor. So pH plays a crucial role in the study and functioning of the entire cellular systems, biomedical fields, food industry, etc. Everywhere pH sensors are used. So in this study, a novel model of reconfigurable silicon nanowire based Schottky barrier transistor for pH sensor application has been proposed. Reconfigurable field effect transistors are the ones which can be configured as N or P channel by tuning the gate voltages. So they are suitable for acidity and basicity detection due to various advantages, such as since it's reconfigurable, so they can be configured as an N type. They are smaller. They have improved sensitivity, etc. The investigation of the effect of pH value on various parameters such as on the energy band diagram, potential, tunneling rates, etc. has been observed for varying pH values. Here is the proposed sensor model. It is a double-layered model consisting of a stern layer, silicon dioxide layer, and it consists of pH solution cavity, which you can see in the blue color. So here the electrolyte or the solution can be added, which can be detected according to the reference electrode. The parameters have been shown here with the channel length and the source and drain work function, etc. Literature survey, we have used various papers to refer to our model so that the results obtained can be verified. So these include various papers regarding TFET, tunnel field effect transistor, DL-TFET, and other reconfigurable field effect transistors that have been uh, uh, made as such. Objective, a reconfigurable field effect transistor is the one that can be transformed into N or P type by tuning the gate voltages. So the goal of this work is to investigate the RFET device for pH sensing application. pH sensors, they offer distinct advantages such as rapid response time, high dynamic range and versatility without increasing the need for scaling. Reconfigurable nanowires, they also offer large surface area to volume ratio, which provides number of active sites for pH dependent reactions. Okay, so despite the above advantages, reconfigurable FETs, they offer comparatively a little less sensitivity, which can be further improved. So to improve the sensitivity of pH sensors, we have simulated this device. Methodology, the pH sensor has been simulated using Silvaco Atlas TCAT tool. The various models which we have used in the paper in the model involves universal Schottky tunneling model, UST Schottky, read hall recombination model, SRH, ZVT, BVT, etc. So all these models have been used in the simulation of the pH sensor. So in this paper, for the first time, we have proposed a comprehensive study of reconfigurable field effect nanowire based Schottky barrier transistor for pH sensor. It is a new model which we have simulated. So the results here are the various results which we have obtained for energy band diagram, potential, tunneling rate, IDVGS graph. So in this, we can see as the pH value increases, the energy is also increases. So for varying pH values, we have obtained the energy band diagram. So for N type as well as P type, we have obtained the results. This is for energy band diagram. Here is the potential. We can see the pH increase as the potential decreases. Here, similarly, other results have been shown for electric field, for transfer characteristics. Now coming to sensitivity, we have obtained the VTH, ion, and ion by ion sensitivity for configuration. The left one, the A part is for VTH. This is for ion by ion, and the third one is for ion by IOF. Various for NMOS, we can see that it's shown in black, and for PMOS, it's in red. The control gate and control gate voltage has been set to 1 volt, and accordingly we have simulated it. Now coming to the comparison of the of our model with other specs, ions and transistors. So in our model, we obtained an ion by IOF sensitivity of 576.28 into 10 to the power 6, which was for a range of 1 to 13, and for NE also it was 12.54 into 10 to the power 6, which was much higher than other models such as for silicon SFET and PC SFET. So in that way, we have obtained a sensitivity which is much higher and better than other models which have been shown. Conclusion, in comparison to silicon SFET based pH sensor, in the NMOS configuration, the ion by ion sensitivity improved by 338 times, and for PMOS, the sensitivity was 7.38 times better than the silicon SFET. So these findings show the potential of our model as a highly sensitive and effective pH sensor. Although there are various future scopes that can be more improvements that can be done in this pH sensor, such as the VTH sensitivity. It wasn't able to cross the nurse limit. So we can do more upgradation and improve the device so that it can perform better and can thus be useful in the industries. Here are the references. Thank you.
Okay. So here in this work, what are the different applications?
So pH sensors are used in many industries, such as food industries, or for even determining the nature of the cells, the trees, the environment, etc. Everywhere they are used. So in those industries, we can use these pH sensors because they are small in size and thus can be of great advantages.
So by that you can know it is acidic or alkalic, like that.
Yes, sir.
Okay.
So we have taken a reference voltage which will help us compare the given electrolyte or whatever substance it is with that, and we can thus determine if it is acidic or basic.
So basically more application on food processing type of industry.
Yes, sir, there are greater advantages.
Okay. Okay then, good. Thank you.
Okay. Thank you, sir.
Thank you. Go on. So with this, all the papers are presented for this session or say in this track. Okay. Thank you all for joining. Thank you.